Well, I've said already that the young generation is split into multiple sections, and actually that's to make this process even more efficient than what I've just described. The young generation is split then into three sections called Eden, S0 and S1. S0 and S1 are called the survivor spaces. To explain how this works, let's imagine our application has just started, so at this point all three of these spaces are empty. What I'm explaining here actually is how this works in Java 8. From Java 9 onwards it can actually work a bit differently to this, but I will explain that in the next chapter. When an object is created then, it's placed in the Eden space. When the Eden space gets full, which will happen quite quickly because it's pretty small, then the garbage collection process will take place on the Eden space and any surviving objects are moved into S0. Our application then continues running and new objects are created in the Eden space. The next time that the garbage collection process runs, the marking process looks at everything in the Eden space and in S0, and any objects that survive get moved into S1. So now all these surviving objects are in S1 and S0 and Eden are both empty. Again, more objects are created and Eden gets full again, and the garbage collection process takes all those that survive, but this time it looks at Eden and S1 and it moves any surviving objects into S0. So what's going on here is that S0 and S1 are two parts of the young generation that are used to swap the surviving objects. There's no meaning to the 0 and the 1. There's no priority here. They take alternating turns in holding the objects that are surviving. So what's the impact of this structure? Well, first of all, every time we do the marking process, we're actually not looking at the entire young generation. We're looking at about 2/3 of it. We're looking at the Eden space and either S0 or S1. So that's slightly more efficient because we've got a smaller space to consider. What we will then have is lots of garbage collections that will be extremely quick. Eden is small, so that's a very small space to sweep, and most of it will be discarded as objects often live for a very short time. And the process of compacting, the idea of moving all of the surviving objects into a contiguous area of memory, is very quick because we've got an area of memory reserved just for that, either S0 or S1, whichever one is not currently being used. Now there is one really minor negative impact from this, which is that at all times either S0 or S1 will always be empty. So there's a small amount of memory that will always be unused, but that's a really minor trade-off for the performance improvements that this process gives us. Actually, you might remember back to an example a couple of chapters ago. We were looking at the heap graph and we knew that our application had run out of memory. We had a 50 megabyte heap and yet only, it looks like it's about 46 megabytes in this example had been used. The other 4 megabytes couldn't be used. And now we know why. This remaining 4 megabytes, or at least most of it, is actually one of the empty survivor spaces. But back to what we were talking about, and each time that an object gets moved from S0 to S1 or from S1 to S0, we say that this object is now one generation older. So an object that has been swapped between S0 and S1 say 5 times will have survived 5 minor garbage collections or 5 generations. After a number of these swaps, the object is determined to be a long surviving object and will be moved from S0 or S1 into the old generation. So the threshold for when this happens, how many generations an object needs to survive, is something that is configurable, and we'll see how we change that and what it is when we get to the next chapter on how we can tune the garbage collector. So everything we've just been talking about then is a minor garbage collection. This happens very, very frequently, and as it happens, objects are being moved between S0 and S1 a few times, and eventually they find their way into the old generation. And when the old generation gets full, as we've previously discussed, a major garbage collection will take place, which is a much slower process. But in a well-performing application, these major garbage collections should be pretty rare.